Hello there. This is sections 2.2, specifically on bond line structures. And your book does a pretty good job at giving you a nice reason as to why you would use a bond line structure. But honestly, for me, the number one picture that convinces me is this one, where if you look at this structure, this is amoxicillin. It's a very important antibiotic that doctors will prescribe for serious infections. And you can see it's kind of difficult to tell really what the structure is. Like there are so many lines here and so many dots that you have to really look carefully to try and pick out like, okay, that's a C double bond. And okay, that's a four-membered ring there. It's difficult to see. What is much easier to communicate is when a structure is in bond line form. Here, you can look at this structure and you can say, okay, I understand where the important connections in this molecule are, and in general, kind of like what the shapes are that we're talking about. You know, we don't need all of the lone pairs in a bond line structure. We don't need to see all of the hydrogens in a bond line structure. We can actually start to communicate these much more difficult looking structures if we're using a bond line structures. Now, I would like to switch over to the notebook so that we can talk a little more in depth about how to draw bond line structures. Okay, so they're actually pretty easy to read and to draw. So first, let's look at how to read them, because you know, I guess when we were kids, we learned kind of how to read and write at the same time. Um, and in this foreign language, which is organic chemistry, we're going to kind of do the same thing. So let's start with some random chemical. I'm going to just like draw some zigzag lines. Okay, this is a bond line drawing. And what's important to note in bond line drawings is that every time you have a corner or an endpoint, that tells you that it's a carbon. Okay, so here we actually have several of these. And you can count them. 1, 2, 3, 4, 5, 6. This has 6 carbons. And in fact, let's add another one. Let's add a 7th, just for fun. There we go. 7 carbons. Okay. A structure with 7 carbons can have a lot of different forms. Whoops. I should be neater. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. There we go. Okay. So 1, 2, 3, 4, 5, 6, 7. So that is the extrinsic information that we're given in this molecule. There are 7 carbons, and we can tell where all the connections are made between those 7 carbons in terms of which carbons are connected to other carbons. But it's really, really important to remember the information that is not shown, the intrinsic information. And that is, let's draw this one again, the bottom one. 1, 2, 3, 4, 5, 6, 7. It's very important to remember that there are actually hydrogens attached to these carbons, and they're not shown in bond line drawings. You can't forget that. That is very important to remember that hydrogens are here and to remember how many hydrogens go with each carbon. Okay. In addition, you can also show double bonds and triple bonds. So in double bonds, like let's say double bonds are shown by just drawing 2 lines, and triple bonds are shown as 3 lines like this. That should be neater. There we go. Where you can kind of see how there's a in triple bond specifically, there's like a point here with a little break in between one bond and the other. And that kind of gives you a clue that the triple bond itself is a separate thing, because if they were connected, it would be very difficult to tell. Okay. Now, additionally, you don't just have triple bonds. You can also have, oxygens, sulfurs, just like we saw in the amoxicillin drawing earlier. And in those cases, let's say we're also drawing a ring, you can have some molecule here. And something else you should notice, in addition to how we now have clearly communicated what the structure is, that there are hydrogens here intrinsically, remember? Okay. Something else to remember is that lone pairs are not shown in a bond line drawing. If you see lone pairs in a bond line drawing, that is uncommon. Sometimes they are given, but sometimes they are not there. So you always need to remember to do your valence bond count each time to determine what the lone pair should be on a molecule, because this nitrogen has a lone pair of electrons here. And we'll do some quick practice in determining a molecular formula from a bond line structure. So if I was to give you this molecule, that's a bond line structure that corresponds to a formula of C3H8O. And that comes from C1, 2, 3 with H1, 2, 3, 4, 5, 6, 7, 8. And the O is here. Similarly, if we have like a ring, for example, this has a formula of C1, 2, 3, 4, 5, 6, C6, H2, 4, 6, 8, 10, 12. Or is that right? 2, 4, 6, 8, 10, 12. It's right. So you can see that it'll take some practice, but you'll get used to understanding what information is intrinsic and what information is extrinsic in these bond line structures. So then how to draw them is that whenever you are drawing, for example, double bonds, let's see. So let's draw a double bond. In a double bond, you always draw things coming out at these types of angles. This is good. Yes. If you draw them like this with the opposite side angles, that's very bad. Nope, very bad. So don't draw those double bonds like that. That goes also for, oh, I'm sorry, that was very bad. For ketones. These are called the ketones, the C double bond O. For these types of molecules, this is good, that's bad. Last, one little note, because we'll go over this kind of a lot, is that whenever you are drawing a heteroatom and it has a hydrogen, the hydrogen has to be drawn. Okay, so if you draw this molecule, if you showed that to someone, this person in organic chemistry, you know, as a foreign language, would understand this molecule to equal a negatively charged nitrogen with two lone pairs. You must always, always draw heteroatoms, which means nitrogens, anything other than carbons and hydrogens, you must always draw them with a hydrogen if they have one, so that you can get an accurate count of the charge and the lone pairs. One last thing before we stop for this section is that spatial orientations of drawings don't really matter as long as all the angles look right. So if you have this molecule, it's the same. Whoops, that's a bad one there. There we go. This molecule is the same as this molecule, because you can kind of freely rotate any of these bonds around without affecting the what the bond line structure actually means at all. A lot in the same way that we were talking about that with the Lewis structures when I was drawing them for you in chapter 1. Okay, so there's definitely more to say about this, but in general, make sure that you remember what, I'll stop the screen, I'll stop sharing here. Make sure that you remember specifically what information is intrinsic and extrinsic in the bond line structures, and also remember how to draw them, and remember what information you are losing. Again, which information is intrinsic with each way of drawing. This has been section 2.2.